All right, so get ready, because today we're going to be looking at quantum teleportation.
Wow.
With this essay by Jorgo Schneppat.
Okay.
It's called Quantum Teleportation. Datenübertragung der Zukunft, which I think roughly translates to data transmission of the future.
Yeah, it sounds very futuristic.
Yeah, and this is going to be a deep dive into some seriously mind-bending stuff.
You know, it's funny you mentioned that mind-bending aspect because I think the first thing that pops into most people's heads when they hear teleportation is Star Trek.
Oh yeah, for sure. It's all beam me up, Scotty.
Exactly. But Schneppat makes it clear right away that's not what we're talking about here.
Yeah, no instant human travel this time.
No beaming people up, unfortunately. But what we are talking about is the transfer of information.
Okay, so not the physical stuff itself, but the information about it.
Exactly. It's like, imagine if you wanted to send someone a recipe for the perfect chocolate chip cookie.
Okay, yeah.
You wouldn't be sending the actual cookie, you'd be sending them the information they need to bake it themselves.
So in this case, the recipe is the quantum state of a particle.
You got it. That's the information we're trying to teleport.
But I gotta say, particles in the quantum world, they don't exactly follow the normal rules of baking, do they?
No, they definitely don't. Think of it like this. A regular coin can land on heads or tails, right?
Right.
Well, a particle spin is kind of like that, but in the quantum world, it can be both heads and tails at the same time until we actually measure it.
Wait, hold on.
That's what we call superposition.
So it's like the recipe says, add a maybe chocolate, maybe vanilla chip, until you bake it and see what you get.
Exactly. We're teleporting the information that describes that weird, maybe both state.
And to do that, we need entanglement.
You got it. It's like having two of those coins linked together in a way that even if they're miles apart, knowing the state of one tells you instantly the state of the other.
Okay, so that's where the spooky action at a distance comes in. I know Einstein wasn't too happy about that idea.
No, he was not a fan. But it's been proven time and time again.
And these entangled pairs we use for teleportation, they have a special name, right? Bell states.
Precisely. They're kind of like the secret ingredient that makes the whole teleportation thing work.
So we've got our maybe ingredients, our spooky link coins, and our secret sauce. How does the actual teleportation happen?
Schneppat lays it out like a step-by-step dance.
Okay.
We have Alice, our sender, and Bob, our receiver.
Makes sense.
They each get one of those entangled particles, so they're instantly linked.
Right.
Alice also has another particle whose state she wants to send to Bob.
Got it.
She then performs a special measurement on both of her particles at the same time.
Now this measurement,
Yeah.
it's not like just looking at them, right? This actually changes things.
You got it. That measurement forces Alice's particle, the one she wants to teleport, to choose a definite state. And because of that entanglement, Bob's particle instantly reflects that change, even if he's a miles away.
Whoa, that's crazy. So does that mean Bob's particle becomes an exact copy of Alice's original particle? Like a clone?
Not quite. One of the fundamental rules of quantum mechanics is that you can't just clone a quantum state.
So no copy-paste?
Nope. The original particle that Alice wanted to teleport, gone.
Poof.
But Bob now has a particle that perfectly matches the original before it was measured.
So it's like the information was transferred, not copied.
Exactly.
But how does Bob actually know what that information is? Does he just look at his particle?
Well, that's where things get a little bit more complicated.
Uh-oh.
He doesn't immediately know how his particle changed. Alice actually has to send him the results of her measurement, and she has to do it using regular communication channels.
Wait, so we still need the regular internet for this?
For now, yeah. Think of it like Alice sending Bob a text message with a decoder key.
Huh. Seems a little less futuristic than I was picturing.
Well, we're not quite there yet.
So Bob gets this message, then what?
Then he can use that information to manipulate his particle in a specific way, based on what Alice tells him, and bam, he's recreated the original state.
Wow, that's pretty incredible. But how did we even figure all of this out in the first place?
Well, Schneppat highlights some really important work that paved the way.
Yeah.
In 1993, there was this groundbreaking paper by Bennett and others that showed, at least mathematically, that teleportation was possible.
On paper, at least.
Right. But then just a few years later, in 1997, two teams, led by Zeilinger and Baumeister, actually went and did it.
So they teleported something in real life.
They did. They teleported the state of a photon. It was a huge moment for the field.
That's amazing.
It really was, and things have been moving pretty quickly ever since. And it's really remarkable to see how far we've come since those early experiments. Schneppat doesn't just stop at the science, though. He goes on to explore all sorts of possibilities.
Yeah, the what ifs.
Exactly. Like, what could we actually do with this technology?
Yeah, that's what I'm really interested in. What's the point of all this?
Well, one of the biggest potential applications is in the realm of security.
Security.
Yeah.
How so?
Imagine a world where you could send a message and be absolutely 100% certain that no one could intercept it.
Okay, that's pretty good.
That's the promise of quantum cryptography.
And teleportation plays a role in that.
A big one. Remember how we talked about measuring a quantum state changes it?
Yeah.
Well, we can actually use that to our advantage.
Yeah.
Let's say you want to send me a top secret message.
Okay.
Instead of sending the actual message, we use teleportation to share a secret key.
A key?
Yeah, that key is encoded in the states of those entangled particles, and if anyone tries to peek at them, boom, the key changes.
So we know someone's eavesdropping.
Exactly. It's like having a lock where the combination changes if someone tries to pick it.
Wow. I guess you could call that pretty secure.
It's called quantum key distribution, or QKD for short, and it has the potential to revolutionize cybersecurity.
I bet the government's pretty excited about that.
They are. But Schneeppot also talks about how teleportation could have huge implications for another exciting field, quantum computing.
Yeah.
Remember, quantum computers rely on those delicate quantum states we talked about, superpositions and entanglements, to do calculations that would take regular computers forever.
Yeah, but I've heard that building these quantum computers is incredibly difficult.
That's true. They're extremely complex and fragile, but teleportation could offer a way to overcome some of those challenges.
Really?
Imagine a giant quantum computer with different components spread out, maybe even in different rooms.
Okay.
Teleportation could let us connect those parts instantly, transferring information between them without losing any of that delicate quantum information.
So it's like a quantum internet inside the computer itself.
Yeah, that's a great way to put it. It could be a game changer for the field, enabling us to build these super machines that can solve some of the world's most challenging problems.
Well, that's certainly exciting, but honestly, my brain is already starting to hurt a little bit, and then Schneeppot takes it even further.
What do you mean?
Well, he suggests that teleportation could actually help us understand the universe itself.
I know, right? It sounds crazy, but hear me out. Remember Entanglement? Those linked coins.
Yeah.
Well, some physicists believe that that connection might be fundamentally tied to the fabric of space-time.
Wait, so teleporting information could tell us about gravity?
Potentially. By doing experiments with teleportation, especially over long distances, we could test some of those theories. Imagine teleporting information to a satellite or even to another planet.
Whoa, okay, yeah, that's definitely next level. But all this talk about this incredibly powerful technology, it makes you wonder.
About what?
If there are any downsides. Schneeppot doesn't shy away from those, does he?
No, he doesn't. He acknowledges that like any powerful tool, quantum teleportation comes with responsibilities.
Right, like earlier we were talking about unbreakable encryption.
Right.
That's great if it's protecting our data, but what if it falls into the wrong hands?
That's a very real concern. Schneeppot points out that this technology could also be used to break existing encryption.
So it's a double-edged sword.
It is like many powerful technologies.
Yeah. And what about privacy? Just imagine a world where even our thoughts, our memories, the things that make us who we are, could be teleported.
It's a pretty wild idea, isn't it?
It's a bit terrifying if you ask me.
It raises all sorts of deep questions about what it means to be human in a world where information isn't bound by physical limitations.
Yeah, we need to start thinking about these ethical implications now.
I agree. Schneeppot really stresses the need for ethical guidelines, open discussion, and careful consideration of the future we want to build with these powerful tools.
Yeah, it's definitely something to think about. It feels like we're on the edge of something truly revolutionary, and we've only just begun to explore what's possible with this technology. You know, as we're wrapping up this deep dive with Yorgo Schneeppot,
Yeah.
one thing that really sticks with me is this idea that we're sending information,
Right.
not matter.
Uh-huh.
But honestly, I'm still trying to wrap my head around what that actually means, like in a practical sense.
I get it. It really challenges our whole understanding of what information even is, you know?
Yeah, like normally we think of information as being physical.
Right, like words on a page or a photo.
Exactly. It has to be attached to something, right?
But in the quantum world, information is all about these really strange and delicate states, like those superpositions and entanglements.
So it's not so much about the particles themselves, but more about the connections between them.
You got it. It's like the information is woven into the fabric of reality itself in those relationships between particles.
Wow. And when we teleport that information, We're not sending any kind of physical object.
Oh.
We're just recreating that specific pattern, the essence of the information, somewhere else.
It's more like sending a blueprint for how to arrange those particles in a specific way.
It's mind-blowing.
It really is.
It makes you wonder, is there an even deeper connection between information and reality? Like maybe information is the most fundamental building block of the universe.
Some physicists believe that. They think that information might be even more fundamental than matter and energy. It's definitely a pretty wild concept, and teleportation gives us a little glimpse into that possibility.
So to bring it back down to earth for a minute,
Okay.
what are some of the key takeaways from Schneppat's essay?
I think the most important one is that all of this isn't just science fiction anymore.
Yeah,
The quantum revolution is happening right now.
right in front of us.
And technologies like quantum teleportation are leading the charge. They have the potential to completely change the world as we know it.
How so?
Well, think about how we communicate, how we compute, even how we understand the universe itself. Could all be transformed by these quantum technologies.
So we need to start preparing ourselves for a future where this is all just a normal part of life.
I think so, and that means understanding not just the science, but also the ethical and social implications.
Right.
Schneppat really emphasizes that in his essay. We need to be having these discussions now as a society so we can make sure we're using these powerful tools responsibly.
Well said. Well, I think he's certainly given us a lot to think about. So that wraps up our deep dive into the fascinating world of quantum teleportation with Yorgo Schneppet.
It was a great discussion.
Thanks for joining me today.